My dear friends, welcome to Rajashekhar classes on applied data science with Python. This is lecture number 541. In this lecture, I will continue my discussion on training a single neuron model. Before understanding this lecture, I request all of you to go through my previous lecture, that is lecture number 540. This is the slide which we discussed in my previous lecture, that is in lecture number 540. If you write in vector notation slightly, what is in W star equal to argmin over W summation I equal to 1 to n yi minus f of W transpose xi whole square plus regularization. Regularizer to avoid overfitting. And how do we solve this problem? Let's go to step 3. What is step 1? Step 1 is to define loss function. Step 2 is to pose optimization problem. Step 3, solve the optimization problem. For this, we studied SGD. What is that SGD? Stochastic gradient descent algorithm, which we discussed in our previous lectures. We studied how SGD works, isn't it? What is this initializing? What you have to do? Initialization of WIs. WIs means weights. This is the first step in SGD, stochastic gradient descent algorithm. The first step is to initialize weights. Let's do some random initialization. Of course, this is very active area of research. Let's do some random initialization. Compute derivative. What is derivative? Del of L with respect to W. So here it is the vector derivative. What is my vector derivative? Dou L by dou W1, dou L by dou W2, dou L by dou W3, dou L by dou W4. Your W belongs to R4 because your Xi belongs to R4. In this example, your Xi belongs to R4. That's why your Wi belongs to R4, because you have 4 values. Xi has got 4 values, isn't it? Yes, what is Xi1, Xi2, Xi3, Xi4? These are the values of Xi, isn't it? Yes. What is my W new? W new equal to W old minus eta into del of L with respect to W old. That is vector notation. What about my scalar notation? Wi new equal to Wi old minus eta into dou L by dou Wi old. That is scalar notation, isn't it? We keep repeating it. We keep repeating it. Have a for loop for iteration equal to 1 to k. They keep running this. Within the iterative loop till they converge. This is the core idea in SGD. First you initialize. In SGD, first you initialize. Compute the second one is compute the derivative, and you update your weights, isn't it? Update your weights. So the key aspect in SGD, so the key part here is computing the gradient or grade, isn't it? Computing the gradient or grade. So in standard gradient descent algorithm, we compute this derivative del of L with respect to W using the points, using all points. I can say using all of my points, Xi's and Yi's. That is standard stochastic gradient algorithm. In the case of SGD, I will approximate this gradient by taking one point Xi and Yi or small set of points. So small set of points or small batch of points. This is what is your SGD isn't it? This is called batch SGD because we are using bunch of points to compute this derivative. Now, the question here is, how do you compute this derivative? So let's go to our neural network model. This is my neural network model here. So you understand it better. What is my the diagram which we discussed in previous lectures also. Here loss, what is my L is known as squared loss, isn't it? The squared loss in the case of regression. Now let's go step by step. So you want to compute compute what is this del of L with respect to W, that is dou L by dou W1, dou L by dou W2, dou L by dou W3, dou L by dou W4. Now let's see how to compute each of them, because your W1, W3 and W4 are independent. So let's say dou L by dou W1. If you look at the path here, so you want to compute the derivative of L with respect to W1, that is dou L by dou W1 equal to dou L by dou F into dou F by dou W1. This is called chain rule of differentiation. What is this? This is called chain rule of differentiation. I am taking the path from W1, isn't it? I am taking this path. I am taking the path from W1, this path, isn't it? I am taking path from W1 to L. Here, what am I doing? I am taking this path. This is W1 to L. That is the basic idea, isn't it? Just let me say like this. This is W1 to L. L means this one, isn't it? I am taking the path from W1 to L. Remember, all these xi1, xi2, xi3, xi4 are constants. Your yi cap is also constant. All these are coming from training data. Xi's and yi's are coming from training data. The only variables here, what are the variables? W. So find derivative with respect to W1 if I just follow this path. How can I find derivative with respect to W1? Just I must follow this particular path, isn't it? This I just what is this? From this which is coming to, it starts from this edge till L, starts from W1 till end, isn't it? Here I need to compute dou L by dou F. Dou L by dou F, how can I compute? Just see, dou L by dou F. Just see, this is dou L by dou F. This is my L. This is my F, isn't it? That is dou L by dou F. This is my L. This is my F. This is dou L by dou F, isn't it? Here I need to compute what dou F by dou W1. How can I compute this dou F by dou W1? Here I have F, here I have W1. Therefore, this is dou F by this path. This path is related to dou L by dou F. This path is related to dou F by dou W1, isn't it? What is dou L by dou F? What is my L? L is sigma I equal to 1 to n yi minus y cap whole square plus regularization. Let's ignore the regularization. Let's ignore it for a while. Y cap can be written as what is my y cap? F of W transpose xi whole square. So what is dou L by dou F? Dou L by dou F is, for simplicity, let me assume this is just F. If I say F, what is d by dx of x power n? That is n into x to the power of n minus 1. That is 2 into yi minus f of W transpose xi whole power 2 minus 1, isn't it? Yes, that's what it says. Again, I have to differentiate. If I differentiate, anyway, this one is constant. I will get this. This is simple derivative. Anybody can understand. What is dou F by dou W1? What is my dou F by I can say, if I say single point, I can write dou L by dou Wi equal to dou L by dou I by dou F and dou F by dou Wi. Dou F by dou Wi means what? What is my F? I have function of W transpose xi. W with respect to W is 1. I will left with xi, isn't it? That's basically what will I get? I will get minus 2xi into yi minus y dash, isn't it? Just of course, if you it's simple and straightforward. What you have to do, this is 2 into yi minus f of W transpose xi whole to the power of 2 minus 1. This is dou Li by dou F, if it is takes point wise. Again, what you have to do, dou F by dou Wi. Dou F by dou Wi means this is 0 into 0 minus, what is this W with respect to W? W with respect to W is what? You will left with minus xi, isn't it? That's what it says. Certainly you will get minus 2xi into yi minus yi cap. This is dou L by dou Li by dou Wi. How will I get L? Now, what is L? L is sigma I equal to 1 to n Li. I must take this one. This is L. What is the difference between L and Li? Your L is sigma I equal to 1 to n summation Li, isn't it? Now, what is this? There are W nu equal to W old minus eta into del L with respect to W, isn't it? This is otherwise I can say this is my, what is this? This is my update equation. I can write like this also. Wi new equal to Wi old minus eta into dou L by dou W Wi old. This is known as update equation. Just I request all of you to go through this lecture, try to understand. Once if you find del L with respect to W or dou Li by dou Wi, this calculating weights is simple and straightforward. Of course, there is a learning rate. I already discussed about learning rate in my previous lectures. Just revise this lecture, that is lecture number 540 and 541, so that in my next lecture we will try to understand how to train multi-layer perceptron. Once if you understand how to learn how to train single neuron model, it is easy to understand training multi-layer perceptron. Just go through this lecture once or twice. Certainly you can understand this lecture is one of the important lecture which is useful in my next lecture also. Thank you very much.